So here we have a quick little PowerPoint on some of the formulas you'll see in D2. R equals KL over CMA. This is resistance in ohms. The K in this formula is the resistivity of the material in ohms per mil foot, 10.4 ohms per mil foot for copper and 17 for aluminum. The length of the wire in this case is in feet, and the CMA cross-sectional area of the wire in circular mills. Now, if we're given the wire diameter in inches, we can convert that to the circular mill area by first taking the equivalent fractional value and converting it to the decimal value. In this case, 1/4 equals 0.25 of an inch. Then we multiply the 0.25 by 1,000 to convert to mils, and then square the mils to get our CMA, 62,500 in this case. And we can also reverse that process to go from the CMA back to inches if required. Also, something called square mill area is, we can convert square mills, or CMA I should say, to square mills by multiplying by 0.7854. Another formula they'll show in the book is P is proportional to E squared. Now you might recall from the other formulas that we see from the Ohm's law exercise that P is equal to E squared over R. And the reason this works is in most cases the R, or the resistance, is a constant. We can prove this with using a simple exercise. For example, if we had 100 volts at 10 ohms, we would use Ohm's law to solve for the current of 10 amps, and of course voltage times current gives us power. Now if we hooked up the same resistance to 50 volts, we would get half the current, which should give us 1/4 of the power. If we doubled the voltage, we'd get double the current, which would result in quadruple the power. So you can see that if we half the voltage, we get 1/4 the power, and if you double the voltage, we get quadruple the power. Now if we had 3 times the voltage, we would have 9 times the power. 9 times larger if it was more voltage, or 9 times smaller if it was less voltage. Now let's look at a heater rated 240 volts, 1500 watts. How much would it produce if we connected it to 120? Now we could find the resistance of the heater based on these values, its original rating, or we could just go to a shortcut using our formula P is proportional to E squared. In this case, the E squared value is the change in voltage squared. So since the heater is rated at 240, I would take 120 divided by 240, which is half the voltage, square that value, and we can see that it's 0.25, which is 1/4 of the voltage or power. So when connected to 120 volts, this heater will only produce 1/4 of the power, 375 watts. This is also true for torque. So if we had a motor, 3-phase motor that was rated for 240 volts, and we hooked it up to 120, we'd only produce 1/4 of the torque. Also in the first section is induction formulas, where L is inductance in henries. That is equal to the number of turns squared in the coil times the permeability of the core material in Webers per amp turn meter. This goes back to magnetism in first year. Also the cross-sectional area of the core in square meters divided by the length of the core in meters. So we could see there that by looking at the formula, if you increase the number of turns in the coil, the inductor, you would increase the inductance in henries, which is also true for the permeability of the core and the area of the core. Now, a lot of cases we have iron core inductors. There's also something called an air core inductor. Air has a very poor permeability compared to iron, so an iron core would give you a greater value in henries. In regards to inductors, the voltage here, E, is the average voltage generated during a time, delta T, in volts. So basically, as our AC goes positive, our coils of wire of the inductor are cut, and this produces something called the back EMF, or a counter EMF, self-generated, self-inductance, and it is indicated there with the minus, that it is actually a negative voltage or a counter EMF. The delta T is the amount of time it took for the current to change. And I over delta T is the average rate of change in current over time in amperes per second. You'll be required to use these formulas in the self-test for D2. We also have T equals L over R, and T once again is one time constant in seconds, and L is our inductance in henries. Once again, our resistance is the circuit in ohms. Will give us one time constant. Of course, our current would be considered 100% or very close to 100% or steady state value after 5 time constants. Another formula we didn't look at too deeply, but it is covered in the module, is W equals 1/2 the inductance I squared. In this case, W is the energy stored in the inductor in joules, which is a value of energy. L is the inductance of the circuit in henries. And of course, the current is the steady state current value squared. We can calculate the joules of the inductor, or the energy stored in the inductor. And if you recall, you might remember that a joule per second is equal or the equivalent to 1 watt. Very similar to a coulomb per second is related to ampere. We also have the capacitance formula. C is the capacitance of the capacitor in farads, generally written in microfarads, but to do the math we need to convert to farads. K is a dielectric constant of the material, and A is the area of each plate in square meters, and the D is the distance between the plates in meters. And our 8.85 times 10 to the negative 12 is the permittivity of free space. So it's a constant that we use. And you could just ignore that when you're doing some math and just throw some values in to figure out a capacitance. Once again, this will be used in the self-test. For charging a capacitor, T equals RC. So T once again is the time constant in seconds, one time constant. Our C is our capacitance in farads, and R is our resistance of the circuit in ohms. So if we have those two values, we can figure out our one-time constant, and a capacitor is considered fully charged after 5 time constants. Also, although it's not covered in the module, you will be required to know the resistor color code. So if we start off with brave for black, boys, brown, raced, red, hour, orange, young, yellow, girls, green, but, blue, violet, and violet is violet in this case, gray, last name, for gray, 1, for white, and for tolerance, gold, silver, Godspeed, and no color. Now we'll always start with 0 and number accordingly. If you get to 10, you've done it wrong. And also for the multiplier, you would start with 10 to the 0. Anything to the 0 is 1, and then when you fill in the rest, 10 to the 1, they should all match to get the proper multiplier. Tolerance for gold is plus minus 5%. Silver is double that, plus minus 10, and of course, no color is plus minus 20. That's the end, so we'll carry on with another PowerPoint later on for 3-phase.